This mini-bite is for revising exothermic and endothermic chemical reactions, part of C3 OCR Gateway GCSE. Exothermic reactions need to be described in a particular way, and for foundation and standard demand in particular, you need to have the ability to describe key features of an exothermic reaction. The first one is the fact that exothermic reactions actually get hotter. So the release of heat is an important factor. You get an increase in temperature. The reason why we get an increase in temperature is because an exothermic reaction actually releases energy, and in particular an exothermic reaction releases heat energy. On the other side are endothermic reactions, and endothermic reactions are reactions where instead of there being an increase in temperature, there is actually a decrease in temperature and the reaction actually gets cooler. It can be a little bit confusing, the next thing I'm going to say. The reason why endothermic reactions get cooler is because they take in energy. Now, most people would believe that if energy is taken in to chemicals, you would expect the temperature to increase. However, this energy that is taken in is actually used for something. So why do some chemical reactions increase in temperature while some chemical reactions actually decrease in the temperature? There is one key reason, and that's all to do with the bonds. And we're not just talking about bonds that hold the atoms inside the reactants, the chemicals actually reacting together. We're talking about, in addition to that, the bonds that are made between the atoms when the new chemicals are actually made. So let's take an example. Let's say we have chemical A reacting with chemical B. So let's pretend this chemical here is chemical A. And in a chemical reaction, it's going to react with chemical B here. In that chemical reaction, we get two molecules produced if one molecule of A reacts with one molecule of B. And those two molecules we'll call C. The 2 represents the numbers of the molecules being produced. Okay, and we'll look at balancing equations a little bit later on. In order for A and B to be able to react together, something has got to happen. In particular, this bond has to be broken, and this bond has to be broken. When those bonds have been broken, the atoms can rearrange, and a new bond produced here and a new bond produced here. So in any chemical reaction, bonds are broken and bonds are made. In the case of breaking bonds with our reactants, energy has to go in to allow the bonds to break. When the new bonds are made in our products, the opposite occurs. When new bonds are made, energy is released out. If we start with looking at exothermic reactions, in the case of chemical reactions, how much energy goes in to break bonds and how much energy is released when new bonds are made is generally different. In the case of an exothermic reaction, a small amount of energy goes in to break the bonds of the reactants. However, when the new bonds in the products are made, a large amount of energy is released. We see this large amount of energy as heat. In the case of endothermic reactions, a large amount of energy is taken in to break the reactants' bonds. When the new products are made, only a small amount of energy is actually released. This difference in energy, more energy being taken in to break the bonds, means that the reaction will become cooler. So in summary, exothermic are heat increasing reactions. And this is due to the fact that a small amount of energy goes in to break the bonds compared to a larger amount of energy that is released when the new bonds are being produced. In the case of our endothermic, we are talking about a cooler reaction, a reaction that will drop in temperature. And this is for the opposite reason. More energy goes in to break the bonds than is released when the new bonds are made. So that energy goes in to actually break the bonds, and the temperature of the surroundings becomes cooler. If you're doing triple science and you have studied Unit C6, endothermic and exothermic reactions develop further. Energy level diagrams give us the ability to look at exothermic and endothermic reactions in a graphical way. It also brings in the idea of activation energy, the amount of energy that is required to start a reaction. It's the amount of energy that's actually required to break the bonds of the reactants to allow the reaction to occur. So when we look at the graphs, we can see an increase in energy going up the side of the graph and an increase in time as the reaction actually progresses. You always read from reactants to products because you have to read from what you start with to what you produce at the end. When you see a part of the graph going up, like in this example here, that means that energy is being taken in. And as we know already, when energy is taken in, it's all to do with the breaking. On the opposite side of these graphs, you have a section that is a decrease. You can see the energy is going from a high energy point to a low energy point. And this is because the energy has been released out. And that's related to the fact that our new bonds are being made to make our products. When you look at the graphs, you can see how the differences in exothermic and endothermic reactions can be explained just by looking at these. In the case of our exothermic, we can see pretty much straight away that there is a small amount of energy that is taken in to break the bonds. However, when the new bonds are made, the amount of energy is much, much larger. And it's this difference between the amount of energy taken in to break the bonds and the amount of energy released when the new bonds are made that tells us that you're going to get heat being produced, energy being released. In the case of our endothermic reaction, we can see the opposite difference. We can see that going from the reactants, a large amount of energy, a big increase is needed to break the bonds. However, once those bonds are broken, only a small amount of energy is actually released when the product's bonds are made. And again, it's this difference between the reactants and the products that tells us, in this case, energy is going to be taken in overall. And this is the reason why an endothermic reaction will actually be a cooling reaction.